Well, good morning. So Scott has given you the overview of the datum change, and that's just part of the datum change because not only are we going to change the datums, but we're also going to redefine all the state plane coordinates in all the states. And so our current state plane coordinate system here in North Carolina will be redefined, and that's where we're going to see the largest numerical change. Depending on what decisions we make here in North Carolina. And I'll show you some of the rationale, some of the options that we have available, and if we stick with the defaults that the National Geodetic Survey has provided, the numerical changes for that. So we will change from our current North Carolina State Plane Coordinate System to the 2022 State Plane Coordinate System, be the North Carolina State Plane Coordinate System. We will make some changes to our, currently our state plane coordinate system is defined in General Statute 102 here in North Carolina. So we will make that, currently the wording is for the North American Datum of 1983. What we're going to do in anticipation of maybe future changes, we'll change that wording to be more generic so that 10 years from in 2032, if we make changes, we won't have to go in and change our statute. It'll be generic enough that we can just do the technical part and go with that. It's going to be based on what Scott just told you on the new reference system. We will continue to use the same reference ellipsoid that we're using in currently with NAD 83, which is GRS 80. State plane coordinate system will have the three projections. We in North Carolina are a Lambert projection, so we'll remain that Lambert projection. And as Scott mentioned, they're going through and developing a lot of policies. If you have time next on March the 7th, take part in the webinar that they're going to provide. I'm actually going up to NGS next week to discuss with them some of the options we have here in North Carolina to help us make decisions on what we're going to do here in North Carolina. So just a quick history of the state plane coordinate system. Did you know that we have our license tags that says first in flight? Well, we really could have a license tag that says first in state plane coordinates because the state plane coordinate system was actually developed here in North Carolina. In 1932, there was two DOT engineers. I guess they didn't have computers. They were using log tables and slide rules to do computations, and they wanted a more simpler way of computing coordinates. And so they put together this concept of a state plane coordinate system. They sent that information to what was the Coast and Geodetic Survey, and with this concept, it was accepted, and the state plane coordinate system for North Carolina was developed. And then supposedly within a year, they created the state plane coordinate system for all 50 states. So we're really the birthplace of state plane coordinates here in North Carolina. You can see here in this slide just a lot of history, and I'll show you some graphical ones of the state plane coordinate systems. But our coordinate systems have changed over time. Here in North Carolina, not really. We've always been a one-zone system. Some states went from one zone to two zones, or went from two zones to one zones. And you'll see in the graphic some states have multiple zones because of the shape of their states. Whoops. For some reason. So this is just a little history. This is the actual document that documents the concept here in North Carolina of creating the state plane coordinate system. This was a paper that was written in 1937. And if you look in this paragraph right here, it talks about how North Carolina contacted the Coast and Geodetic Survey with the concept of the state plane coordinate system. And undoubtedly, the gentleman that came up with the idea, it talked about he had a sudden death during the time, and another engineer at DOT took it over. But that was the beginning. So we are really the birthplace of state plane coordinates. So this is the state plane coordinate system of NAD 27. And I think there's still one county still here in North Carolina that's still using NAD 27. But you can see, depending on the shape of the state, how many different zones you have. And see, North Carolina, we're a one-zone state. And you can see originally South Carolina was a two-zone state. But when we went to NAD 83, they converted to a single zone. Kentucky, you can see it was a two-zone state. They actually have two zones plus a state zone. So they have basically three different state plane coordinates, a two zone and a one zone. And you can see states that are long don't really have the shape to fit like North Carolina, where they're long east-west and narrow north-south, like Texas, they have multiple state plane coordinate zones, and they had 27. And then here's some changes that occurred before we went to NAD 83. You can see a state plane coordinate system down in the Gulf. And then up in Michigan and California, they added some additional zones there too. So this is currently our NAD 83, what we're currently in. You can see in North Carolina, we haven't changed. We're still a single zone state plane coordinate system. And you can see this is where South Carolina made the change from two zones to a single zone. So what's we got to do here in North Carolina? We have basically two concepts we can approach it. One, we can make decisions that the coordinates change as small as possible, which would, one of the big impacts is going to be to our land records management system. All 100 counties have a land records management system, and that's based on the state plane coordinate system, the PIN numbers. And so if we change those coordinates by a large amount, then that's going to impact the PIN numbers. So by keeping the change small, that will keep from having that impact on the PIN numbers. Also, all our statewide imagery is the tile systems on our state plane coordinate system at even coordinates at the corner of the tiles. So we make large changes that's going to impact those tiling systems. The other argument is we change them by a large amount, then graphically, visually, they will very, very clearly that they're on two different datums and two different state plane coordinate systems. So those are the two things we've got to look at. And then the last bullet there, if we change them by a large amount, that will satisfy all of NGS requirements. So we meet all their requirements, the values will change by a large amount. So these are the characteristics of the change of our new state plane coordinate system. One is we're going to minimize distortion to have a more topographically fit-in state plane coordinate system. In other words, that state plane coordinate system is going to more closely fit the topographic service than it currently does. We will stay on a Lambert projection. We'll go from a two parallel system, and I'll show you a graphic of this, to a one parallel system. And you can see some of the other requirements is that the central parallel has to be defined to the nearest arc minute. And by NGS requirements, the coordinates must change at least 10,000 meters. So that's one of the requirements. We meet all the requirements, then the coordinates will have to have that large change. And the grid origins will have to be round to the nearest 1,000 meters. So, what can we do here in North Carolina? If we accept, as I said, we accept all NGS's requirements, then we're going to see numerical value changes of over 10,000 meters, which graphically will be very visually that you know you're on you're not on NAD 83, but it will impact the land records management system because that will impact the PIN numbers. If we do no exceptions, we're up around that 34,000 feet. We ask for one minor exception, the change will be around 115 feet. And if we do one minor and one major exception, we can get it down to 2 feet. More than likely, the National Geologic Survey might accept one exception. More than one is probably going to be out of the question. So that's why I'm going up next week, sit down with Michael Dennis and talk about what our options here in North Carolina and come up with recommendations, which I think can be the best solution for us here in North Carolina. So this is our current state plane coordinate system. You can see it's a two parallel system. We have the northern parallel and the standard parallel. At that point, the combined factor is 1. So ground and grid are at the same, and in the middle is where the most distortion is. So you can see in the green areas, that's where your grid to ground distortion is minimized, so obviously near where the parallels are. And in the middle of the state, that's where we had the most distortion when you project it down the state plane coordinates. And we have another challenge here in North Carolina in that we have one of our selling points for North Carolina from the beach to the mountains. So we have low elevations at the coast, and then we have the highest mountain east of the Mississippi here. So no matter what solution we come up with, there's going to be distortions in that part of the state because of the drastic change in elevations. So this is one of the kind of the default state plane coordinate system that NGS has presented to us. As you can see, it's a one parallel system, and you can see a lot more green area, which means has minimized the distortion. Obviously, up in the mountains, you still see some distortion, and then the areas where the largest distortion is in the extremes along the Virginia border and the South Carolina border. And you can see down there in the graphics where it displays how much distortion that is. So this is one option that we're looking at from the National Geodetic Survey. Probably some simulation of this that we may change the false easting, some other things we can take a look at to minimize the impact. And this is just another option. NGS has sent us about 4 or 5 different options to look at, some with one exception, some with 2 exceptions, and that's the decision we've got to make. But the numbers will change. I wouldn't say the numbers will change. The difference between NAD 83 state plane coordinates and 2022 state plane coordinates, numerically wise, will be different. And we need to prepare for that. One of the things we need to prepare for is, as we're collecting that data now, and prepare for 2022, is make sure we have metadata. Make sure the data you collected has metadata with it, so that when NGS provides Ezra and the other software vendors with the science to do the transformation, your data will have metadata that will know it will correctly do the transformation to 2022. The other question I've been asked a lot is, when will we implement this? Well, North Carolina Geodetic Survey, by statute, is by legislation, we official survey base. So what we're going to do is we're going to actually support both datums for a few years, because we know, take for example a DOT project. Some DOT projects last 7 to 10 years. So we know we're going to be in between projects. Local projects last a long time. So the official change will be in 2022, but in North Carolina we will continue to support NAD 83, 2011, NAVD 88, and 2022 for a time period, so that the private sector, local government, state government will have time to do the transformation from one coordinate system to the other. And I'll talk a little bit about our real-time network. We're actually going to run 2 systems once we make the transformation, so that it'll support both NAD 83 2011 and the 2022 reference frame. So that's the kind of the fundamentals of what's going on. So my goal is to make a decision on our state plane coordinate system mid this year. Run it by all the groups, the private sector, local governments, get their buy-in, and then in the 2021, when we have the next long session, we'll make the changes in our statute to reflect the change in our state plane coordinate system. So I'm going to spend a few minutes just telling you what we're doing to get prepared for this. And Scott's already told you about the GravD program, which is very important for heights. Our floodplain mapping program here in North Carolina, the critical element is accurate and precise heights. And so we want to make sure when we go to the new vertical datum that we are providing the users here in North Carolina with the best models that we can provide to them and the best information. And so to do that, we need to make sure we have good gravity data here in North Carolina. So we have been partnering with Scott and National Geodetic Survey to ensure that we have collected gravity data here, both airborne and terrestrial gravity data, that they can use in their models for the heights. So this was 2016, I believe. This was the status of the airborne gravity in North Carolina. So you can see one block in central and eastern North Carolina had been collected. But this area, western from about Greensboro west, had not been collected. So we were contacted by the National Geodetic Survey, and they wanted to utilize some new technology to collect the gravity data in that part. And they were going to use a unmanned aircraft system. And when you think about, when you think of a UAV, you think of flying over a small town or a football field. You don't think about flying over a quarter of the state plus another state you just don't think it's possible. So the UAV they brought down was not one of your smaller ones. It was a 40-foot wingspan UAV. Looked like a regular airplane. And the concept was to put the gravity meter in that aircraft and fly it. But because of FAA rules, they were not allowed to fly it as a UAV. Had to fly it in hybrid mode, which meant it had a safety pilot in it. And the safety pilot's job was to make sure it did what it was supposed to. From what I understand, the safety pilot didn't have to take over during the flight. It was all flown from here in Winston-Salem as a UAV with a safety pilot on board. And this is just the aircraft here, and you can see with the gravity meter in it. So we now have all the airborne gravity data collected here in North Carolina, and that information is now at the National Geodetic Survey. But to supplement that, we also need to collect some terrestrial gravity data. So as Scott mentioned, the meter on the right is an absolute gravity meter. It's around $500,000. So if anybody has any money they want to provide to the Geodetic Survey so I can buy a gravity meter, I'll be very glad to have that. We Barnett partnered with National Geodetic Survey to collect absolute gravity, especially in the western North Carolina. That's where a lot of the gravity, terrestrial gravity data is very old, very sparse. So we're trying to supplement that. The meter on the left is a relative gravity meter. That's about $100,000. And so we've been using both of these on loan from the National Geodetic Survey to establish collect terrestrial gravity data in western North Carolina. And that information has been provided to the National Geodetic Survey and will be used in the next geoid model. The other thing we're doing as Scott mentioned, models. That geoid model is critical to getting precise and accurate heights using GNSS technology. So the more data we have, the better data we have, the more accurate, precise heights you can get. So one of the things that we did last year is a campaign to collect GNSS data or GPS data on benchmarks, marks that have levels. So marks that we've leveled through, we know that orthometric height. And if we collect GNSS data, then we can determine what that difference is at those marks. That data then goes into the geoid model, which then is provided to you as a user. That again allows you to do that. So we did a campaign last year and probably occupied 50 or 60 marks. This is just NGS's screenshot showing you the ones that we have completed, and it looks like I've got one that I need to do one more observation on. So all that again is being collected so that we can have the best model, geoid model that is possible here in North Carolina. The other key component of the new adjustment of 2022 is, as Scott mentioned, the primary way to get to this new 2022 datum will be through CORS, Continuous Operated Reference Stations. And this is our network here in North Carolina. We have 84 CORS here in the state. All but 7 of those are part of the national CORS. And so those will be used as part of the 2022 reference system. And so it's very important that we maintain those and provide that information to the National Geodetic Survey. You can see our build-out plan, the areas with the red stars, that's where the remaining areas that we want to establish new CORS. Then we'll have very good, dense statewide coverage of CORS data. This is just some pictures of some of our CORS. If you haven't ever seen one of our, this is our first solar powered. We established one down at the Old Bonner Bridge to support that project, and also because after a hurricane, there's a lot of mapping going on, and the CORS are needed to support that mapping. And a lot of times we'll lose power, and our CORS will not be available because they don't have power to run it. So we're putting in solar power ones down the coast so that after a storm, those will be resilient and be operational. We're putting a second solar powered one in at Redanthia right now. The one in the middle is one of our typical ground mount towers, and then the one on the right is a building mount. The idea is these are permanently mounted, very stable installations so that we can collect data. So the one in the middle is our ground mount tower, and so Scott and I were talking about, did we install them properly? So he sent me a picture of one that the National Geodetic Survey installed. And it made me wonder, did we install ours upside down? For some reason, they put their tower upside down. And Scott's never explained to me why they did it that way. So.
They never explained to me. So.
I think we put ours in right. I think they put theirs in wrong. So what have we? So kind of summarize where we're at. So we've done a lot of things. The GICC has created a working group. So we have a working group that has representatives from GIS, from agriculture, from transportation, from engineering, from surveying, from property mappers. We're trying to bring all the groups in that use geospatial data and the ones that will be impacted, to sit down and talk with them and help them get prepared for that. We're working with our adjacent DOTs so that there's a transition plan, especially for projects that are near the state border that may be working at the same time. Make sure we have a good transformation between those doing that. I already talked about we've collected the terrestrial gravity data and the airborne gravity data. We're partnering with North Carolina A&T on some research projects and UNC Charlotte. Hopefully we can find some money to buy that gravity meter, because even after the datum change, it's going to be very important to monitor gravity. As Scott mentioned, we have plate movement. So we need to monitor gravity over time to make sure that our gravity model is up to date. And it would be very nice to have that. I mentioned the ellipsoid heights on benchmarks. We're working on that. We've collected statewide LiDAR data. We have QL2 and QL1 LiDAR data. The elevation model will be used by NGS in their geoid model. We have a web page we've created on the North Carolina Jet X-rays that has a lot of information. Scott's web page. So there's a lot of information out there about the change. We're doing a lot of educational outreach. Like today, we're speaking to groups to get them prepared, make them aware of this change. And like I said, I'm going up to the National Genetic Survey next week to get more information to help make a final decision here in North Carolina. Just two slides to close on. So just remember, when you get data from another state, North Carolina, we are officially, the official conversion is U.S. survey foot here in North Carolina. And you can see the other states that are U.S. survey foot. South Carolina is an international foot state. So be careful if you get data from somebody from South Carolina or a state agency. Look at the metadata. It may be in feet, but it is more likely going to be an international foot. So make sure that you're aware of that, because depending on where you are in the state, the difference between state plane coordinates, international feet, survey feet here in North Carolina can be as much as 7 or 8 feet by that conversion. So be careful with that. And then my last slide is, if you're using GPS equipment, we're going to have a GPS rollover on April 6th. So at that point, we'll go from GPS is designed so that there's only 1,024 weeks. And so when it gets to that point, it's called a GPS rollover. Newer equipment will be able to handle this. But if you have some older generation equipment that does not have update firmware, it may not be able to handle this GPS rollover. So if you do have some older equipment, go back, talk to your manufacturers, see if you have the latest firmware. Not only with just equipment, but things like data loggers. A lot of data loggers have a GPS board in them that use it for a timing component. We actually have some in some of our river gauges. And we've already had to update those firmware because the current firmware would not support the rollover. So just if you have equipment, you are using GPS equipment, make sure it won't be impacted by this GPS week rollover. And that's it. Scott and I, if there's any questions, we'll open it up for that.
I have a question. If this is a national program and our state gets 2 exceptions, will there be some pattern that will be acceptable? Like, if we get 2 exceptions, will other states be required to conform, or will we be required to not have exceptions if other states don't have?
Yeah, I think. Yeah, so the question was, if North Carolina got 2 exceptions, does that mean all other states could get 2 exceptions? And I think that's one of the reasons NGS will be very, you'll have to have good rationale to do an exception, because they don't want to start a pattern of, well, you gave North Carolina 2 exceptions, why can't you give South Carolina? So I think to get an exception, I'm going to have to provide very good rationale, and it's going to be on a case-by-case, state-by-state basis to get those exceptions. I think NGS, and Scott can speak for NGS, I think they would prefer that everybody just not get exceptions, but knowing there will be some states there will be good rationale for that. I'm currently also working with South Carolina Genetic Survey, so we're trying to work together so that we can be consistent between the two states. Other questions? Main thing is metadata, and be prepared for the transformation. Don't wait till December of 2021 and say, oh my goodness, we're going to change in 2022. But we will, here in North Carolina, we will support both NAT 83 and 2022 for a time period that we know that to the point where our users have successfully moved over to 2022.
Kind of a follow-up on that one, the PIN numbers, are there other states that follow that same methodology for parcel identifier numbers?
I don't know. Do you know? We don't know. Don't know.
Does that may affect?
Right. For exception, we may be the only state that uses PIN numbers. The complicating factor with the PIN numbers is some counties use it not just for their land records, but they use it, one county uses it for billing. So it goes down to multiple computer systems if we change those. So, all right. Well, thank y'all very much.